Hello everyone. Today we're going to finish lesson 18.2. So we will be spending day 3 on defining and evaluating basic trigonometric functions. So we will be able to evaluate the basic functions using a calculator. So now that you know how to do it without using a calculator, which means finding the exact answer, you can go ahead and use the calculator to double check your answer to see if you got it right. So you will learn how to use your calculators. So get your calculators ready. And let's take a look at the note. It says that since sine and cosine functions are coordinates of the points on a unit circle, the output of the sine and cosine functions will always range from -1 to 1, which means the highest value is 1, the smallest value will be -1. The output for the tangent function can be large because the denominator can become arbitrarily small as long as it's not equal to 0. So tangent is different from sine and cosine, which means that sine and cosine are the only ones that are going to range from -1 to 1. So let's take a look at evaluating the basic trigonometric functions using a calculator. So we need to remember, this is very important, when something is in degree mode, like 45 degree, you need to make sure that your calculator shows D. Some of you should show degree, DEG. When something is written in like pi over 2, anything that has pi or specifically says radian mode, then you need to make sure that you have R or radian on your calculator. So that's very important because this is going to affect your value because we're operating in two different modes. It's kind of like degree and Celsius, right? It's going to be different, or inches and centimeters. They're very different. So it means something totally different. So just keep that in mind. Example 1. Use a calculator to evaluate each trigonometric function. Round to 4 decimal places. So we are asking the calculator to do this. So that's why we want to make sure that we are getting 4 decimal places. So you can go ahead and use your calculators now. Go ahead and take out your calculators and make sure you guys look for sine, cosine, and tangent, those buttons, and make sure you have it. I'm going to see if I can bring that up with my calculator here. So here's my calculator. I'm going to find the tangent, first problem, the sine of 79 degrees. So I need to make sure, because 79 degree is in degree mode, so I need to make sure I switch my mode to degree mode. So make sure the button says degree, okay? And so therefore, I have 79, and then taking the sine of it, so that's going to give me negative 0.4441. And of course, you want to double check it one more time. And let me double check it one more time. I think I pressed the wrong, yeah, there you go. I pressed the C. So you want to always, when it's done on a calculator, you want to make sure that you do it a couple of times to make sure that it is correct. I'm going to do it another time just to make sure we are taking the sine of 79 degrees. So it is 0.9816, and that's what we're going to write down for our answer right here. So because the answer is approximate, we're going to use the approximate symbol, and you're going to write down 9816, and that's what the answer is for the sine. Very easy, right? So make sure you guys have the same answer on your calculator, otherwise you may be getting it wrong. So we're going to move on to find the cosine of -65. Once again, this is in degree mode, so you want to make sure that your calculator is in degree mode. And clear off your calculator. We're going to take 65, and it's negative. So I'm going to make it -65, and then taking the cosine. So -0.562 is what I'm getting. Once again, I'm going to try this again. 65 negative, and cosine 0.422. I'm getting a different answer. I think I typed it wrong again, so I'm going to do it a third time. 65 I think I did 56 earlier. So cosine, okay, now I'm getting a repeat, so 4226. So I'm getting 0.4. Notice the range is less than 1, so it's approximately 0.4226. So notice both answers that we're getting are less than 1, which is within the range because sine and cosine should be less than 1, right? And next, notice that this answer has a pi. So it's 2 pi over 9. So when you see that, you need to switch this over to the radian mode, right? So make sure that your calculator switches over to the radian mode. So I'm going to switch radian mode. So it should say RAD on the top now. And so now I'm going to take 2 times pi divided by 9. So it's 2 times pi. Where's the pi? And then equals, and then divided by 9. Finally, I am going to take the tangent of that, and that's 0.8391. Once again, if you have time, make sure you go through, pause the video, and repeat it a couple times to make sure that you guys getting the same answer every time, right? And so again, this is approximately 8391, and that is the correct answer for both of them, for all three of them. Okay, so go ahead and pause it and practice the next ones on your own now. Make sure you try this on your own before you check your answer. So if you did this correctly, you should have gotten the answer of 3420 for part A, and 8391 for the second one, and the third one is 9848. And so those are the answers for 3 of them. Next, we're going to take a look at the next problem here. Let's read the note together. Using trigonometric functions to find coordinates of any point on a circle as a function of an angle is useful for solving real-world applications. The trigonometric ratios can be expanded to the coordinates of x, y on any point on a circle with radius centered at the origin. So we're repeating the same answers. We're saying that the cosine is x over r, which means it is the adjacent over the hypotenuse. Sine is opposite over hypotenuse. Tangent is opposite over adjacent. And x cannot be 0 because otherwise it will be undefined. So here's another note. When working with real-world problems, the first step is to draw the picture. And always you want to relate it to the right triangle. So somehow you need to draw a right triangle that goes with the problem so that it's mapped up correctly. And so let's demonstrate that with the few examples that are following. So let's take a look at example 2. A 25-foot ladder is leaning against a wall, and forms a 70-degree angle with the ground. So as you read it, you already should start forming a picture. And let's say that is the wall right here. The ladder is leaning against the wall. So here is the ladder. I'm not very good at drawing, but I'll try my best. So the ladder is 25 foot long and it's leaning against the wall, and it forms 70-degree angle with the ground. So here is the ground. How high up the wall is the top of the ladder? So here's the top of the ladder. Basically, they're looking for the height. You can label it H for height or X, whatever you want, that's fine. So we got 3 unknown. We got 2 knowns and 1 unknown. I think we can involve one of the trigonometric functions. So based on this angle, the opposite side and the hypotenuse side, what is that? What trigonometric function can you relate? Blank 70 degree equals x over 25. I'll give you 2 seconds to think about it. You should be thinking sine, right? So the sine of 70 equals opposite over hypotenuse. That's x over 25. The rest is just going to be putting a 1 and cross multiplying. So we have x equals 25 times the sine of 70 degree. And you can use your calculator to get the answer. You should get about 23.5 feet. So go ahead and test it out with your calculator to see if that's what you're getting. You are going to go ahead and try this next problem. So go ahead and pause the video and try the problem. Hopefully you've had a chance to try the problem. Let's read it together. The ramp approaching a loading platform that is 6 feet off the ground is to have an angle of 20 degrees with the ground. Find the length of the ramp round to the nearest 2 places, 2 decimal. So let's go ahead and draw a picture. Here's the ramp approaching a platform. So let's assume that is the platform. And the platform is 6 feet off the ground. And the ramp is at an angle of 20 degrees. So here it is. I'm just going to do something like this to See that? That is find the length of the ramp. So L, they want specific letter. So you want to label that L. And that's pretty much all the information that is given. So based on that angle, that length, and that side, what trigonometric function can you think of? That would be opposite over hypotenuse again. So isn't that just sine of 20 degree is equal to 6 over L? And then cross multiplying. So I have L times the sine of 20 degree equals 6 divided by the sine of 20. And I will have L is equal to approximately 6 divided by sine of 20. And I'm going to round it off. Earlier it says 2 decimals, so it should be 17.54 feet is the answer. That's the end of that problem. And this is another triad problem, so go ahead and pause the video again and try it. Hopefully you've had a chance to try it again. Let's read the problem together. How long a shadow does a 40-foot tall tree cast on the ground if the sun is at an angle of 0.5 radian relative to the horizon? So we're going to do some creative drawing. You can go ahead and do the same on your paper, hopefully. Here's the tree. Here's the sun shining. And then here is, it looks like it is off a little bit. I ran out of space. So let's assume this angle somehow is closed. And so this angle is at a 0.5. It's not degree, it's radian. And so here's the 90 degree. Always straight with the ground, parallel, and the tree is 40 feet tall, so here it is. And then you want to know the shadow. This is the shadow, right? So we're going to label the shadow X. So looking for X. And so the first thing we want to do is make sure that we can convert back to either you're going to be working with the radian mode using the 0.5, just make sure your calculator is in the radian mode. So there's two ways. Or second thing is to convert the radian back into degree, because 1 radian is actually equal to 180 over pi, right? So half a radian should equal to half of 180, which is 90 over pi. So either way is fine as long as you label it correctly. So you can say tangent, if you want to stay in the radian mode, so let's go ahead and work in the radian mode. Tangent of 0.5 is equal to 40 right here, because we're involving the angle, opposite, and adjacent. So that would be tangent. That is why we have tangent 40 over x. So in the radian mode, if you do the math, you would have x times the tangent of 0.5 equal 40. And then x equals 40 over tangent of 0.5. Once again, make sure you're in the radian mode when you're doing the calculation, and you should have the answer of 73.2 feet. Otherwise, you can go ahead and use the 90 over pi and work in the degree mode. So make sure you're in the right mode, okay? So the answer is, the shadow right here is 73.2 feet, okay? Number 3, example 3. A 13-meter flag pole bearing the dragon banner consists of 13-meter shadow. Find the angle of the elevation to the sun. So let's just go ahead and draw the flag. Here's the flag. Beautiful flag right there. My beautiful drawing. It's 13 meters tall, the flag. And then it forms an angle. They want to know the angle of elevation. Elevation means here's the sun. You're looking up at the sun. So here's the angle of elevation. This would be the angle of depression, right? So angle of elevation is the one looking up. So the shadow is 13 feet. So you basically look 13 meters. So in terms of this angle, opposite and adjacent, you're looking at tangent again. So the tangent of theta is actually equal to 13 over 13. And this is in degree mode because you're trying to find a degree, right? Not radian. So it's equal to 1. So the tangent of angle has to be, so to undo the tangent, so we got tangent theta equals 1. So you want theta, so you got to undo the tangent. So we're going to do tangent inverse of both sides. So you need to find the tangent inverse button, and usually it is above the tangent button. So you press second tangent 1, you should have the angle is 45 degrees. Basically, we're saying, hey, the tangent of 45 degrees equal to 1, right? So that would make sense. So this angle of elevation is 45. You're looking up at a 45-degree angle at the sun. That's the end of the problem. Go ahead and try this problem by pausing the video and then come back and check your answer. Let's read the problem. Hopefully you did the problem already. A man that is 6 feet tall casts a shadow of 14 feet long. Find the angle of elevation of the sun. So this is the same idea. Here is this man, 6 feet, and you are drawing a right triangle, 6 feet man right here, sun is here, and the shadow is 14 feet. So they want to know the angle of elevation. Once again, looking up. Oops, the angle. So there is your right triangle right there. So again, considering this is the angle, this is opposite, this is adjacent, we're looking at tangent again. So tangent of theta is equal to opposite 6 over 14. And to find the angle, we got to take tangent inverse of both sides. So that's going to get rid of tangent, and you have tangent is equal to approximately 6 over 14, and then take the tangent inverse, which is 23.2 degrees. And that is what this angle of elevation is equivalent to. So that is what you're looking up at. And that's the end of the problem. And that's the end of the lesson. Day 3, last day. So hopefully you've learned a lot about sine, cosine, tangent, and how to find exact values in real life problems as well. And have a nice day. See you then.